Hi everyone, welcome back on video lecture series in material science and engineering. And this video lecture series is about a heat treatment process for a steel. I have divided whole video lecture series in two parts. This is part 1 and part 2 will comes in after some discussion. In part 1, so I will explain one by one. This is Sachin Kumar, doing PhD in Material Science and Engineering, IIT Kanpur, under the guidance of Dr. Kaustubh Kulkarni, and my research topic is diffusion in nickel-based ternary alloy. Let us get into what are the topics that I will cover in the heat treatment process for a steel 1. In first previous video lecture series, we covered what are the different type of alloys can be formed in a iron, that is a ferrous alloys. That we have covered in between of the video lecture. I used to say the heat treatment process will enhance the mechanical properties. Heat treatment process will change its microstructures. How this heat, so what is this heat treatment? How this heat treatment will changes the microstructure as well as the mechanical properties, we will know in this video lecture series in depth. This is the overview of heat treatment process of a steel 1. Thus, in this video series, I will cover first important topic is stress relieving. So, stress relieving heat treatment. So, we are knowing what is stress relieving heat treatment, what is internal stresses, how it will adversely affect on the mechanical properties, and so what is the process of doing this stress relieving treatment in the steels. We will know these things. Okay. Afterwards, a very famous heat treatment, that is a annealing, we are knowing. So annealing heat treatment are divided into, classified on the basis of temperature. First of all, temperature of a heat treatment, and okay, they are divided in, annealing are classified on the basis of heat treatment, temperature of a heat treatment. That is, first of all, we are knowing, so what is full annealing, isothermal annealing, diffusion annealing, recrystallization annealing, process annealing, partial annealing. We are knowing these things. Okay, so I forgot to mention two more points are there here. Process annealing and partial annealing. Right? So these are based on the temperature of heat treatment. So before getting into the heat treatment process, the basic terminologies that we are using in this are, I'm explaining. I think everyone knows. So what is this phase diagram? This is iron carbon phase diagram. That is steel. Portion. This is A3 line. This is nomenclature. I will explain. So A3 line, ACMS line, and A1 line. This A1 line is known as the eutectoid temperature, and this ACMS line is known as, in hyper-eutectoid steel, the temperature at which the solution of a cementite in the austenite is completed during the heating. Here, of during heating process. This is hyperheterocrat steel. We know this one. During heating process, we know after this temperature, the all the steels are converted into austenitic region. This is a gamma region. Whereas similarly in the case of hypoheterocrat steel, A3 line is the temperature at which the transformation of an alpha ferrite to the austenite is completed during the heating. So we can explain in two ways. That is AR, I will explain AR and AC. AC during heating, this is during cooling. Okay, both A3 and ACMS lines can be an A1 line. All the three can be explained during heating and during cooling. So if it is mentioned as AC3 line and during heating process there is a heating, the temperature at which during heating we are mentioning during heating at temperature at which all the austenitic is transformation is completed, or during AR3 if it is mentioned as AR3 during cooling, the temperature at which the austenitic begin to transform to alpha ferrite during the cooling. So this is only a small difference is there. Okay. So what is the nomenclature? Here in this is French nomenclature. French word they are using. I don't know how to pronounce these words. A stands for arrête. C stands for CHUFFAG, and R stands for REFROCESS. It's too big here. SSEMENT. So this is known as arrest in the correct English meaning, heating, and this is during cooling. This is the meaning in the English terms. So that's why we are mentioning AC. We are arresting during heating, during arresting we are cooling. Okay, this is a nomenclature. This is very important. Be clear. You will get confused during while I am teaching the heat treatment process. I frequently use these words: critical temperature or A3 line, A1 line, AC3 line, AR3 line. They are frequently using. That's why I have explained in the initial stage itself. Okay. Okay, let's begin with the first topic, that is a stress relieving heat treatment. As the name indicates, in most of the metallurgy, the names itself defines process or definition. Here also, the stress relieving heat treatment. The heat treatment which will remove the internal stresses. Internal stresses also called as an residual stresses. Internal stresses or residual stresses. Right? Yeah. This process is employed to relieve the internal stresses. But one more noticeable point in this stress relieving heat treatment is there is no change in the microstructure. The, the microstructure will remains as it is, only it will remove the internal stresses. So in our mind will comes, so what is this internal stresses and how it will be adversely affect the material? Why we want to remove this? Is there any it should be there should be any reason to remove these internal stresses? Let's begin. So what do you mean by internal stresses? Internal stresses are those stresses which can exist within the body in the absence of an external force. Stress that exist within the body in the absence of external forces. If we apply a stress external force, there is an internally body will resist this force by creating some stress inside the materials. So after removing this force, there is a still exists of stresses inside the body, but lesser than this one. These are called as an internal stresses. Okay, how this will be adversely affect the system or the body? The steel with the residual stresses under the corrosion environment fails by stress corrosion cracking, whereas in general the failure by stress corrosion cracking occurs under the combined action of corrosion and extremely applied stresses. This is the first adverse effect of internal stresses. Second is the fatigue life will also reduced due to the presence of internal stresses. When we apply the fatigue load on the material, these internal stresses will act as a stress concentrated areas and there is results in the failure of the material. This is the adverse effect of a internal stresses. To remove these internal stresses, what is the process of this stress relieving heat treatment? First, we have to heat the sample. This is a diagram. First, we have to heat the sample. Heating sample lower than the critical temperature. Critical temperature, lower critical temperature, and hold it for some time. This is start and end time. Afterwards, we have to do the careful uniform cooling. This is very important, crucial also. The uniform cooling, if we are not done any uniform cooling, if it is an uniform cooling, again there is a development of a internal stresses and there is no use of this whole process. So this end of the end process, there is a cooling is also very important. That's why the rate of heating is very short, but whereas the rate of cooling is very long time. So this is a start of cooling and this is the end of the cooling. See the time. So it's approximately 2 times that of the heating rate. That's why we have to do the uniform cooling. Okay, this is for the normally hypohydrocarbon state. It is about 600 degrees Celsius. If you add any other alloying elements, it will take more temperature as compared to that of the this temperature, because we need to because of this alloying element, the temperature is increased. Stress relieving temperature is increased. And finally, there is no change in the microstructures. The microstructure initial as well as the final will remain same. This is the simple heat treatment process to remove the internal stresses, but it will give a significant improvement in the performance of the materials. Okay, this is a first part of first video which will explain the stress relieving alloying. Okay, in next upcoming video I will explain complete annealing process, different kind of annealing process in the next video. Thank you.